Hello, my name's Mrs Adams and I'm the Year Leader of Year 1.
Hello, my name's Miss Taylor and I'm the Year Leader for Year 2.
The aim of this presentation is to go through the national curriculum aims, the structure of a daily maths lesson, how we teach some of the objectives so you can help at home, and the importance of showing your child it in multiple representations so they gain a mastery approach. How do we assess your child in maths? We assess your child the same way as we would do for reading and writing. They are either assessed as working towards the expected standard, working at the expected standard, or working at greater depth within the expected standard. If your child is working at greater depth, it means that they can solve greater complexity of tasks, more problem solving, and can clearly explain their reasoning on how they get an answer. We come to these judgments through the daily work they do in books and looking at how much it's supported by an adult. We also take into account how they perform in tests and assessments.
So, in Year 2, the children complete their SATs testing. They have a arithmetic paper, which is paper 1, and then on a separate day, they will then complete the paper 2, which is problem solving and reasoning.
At Camford Heath Infant School, we follow a mastery approach for maths. This means we spend a longer amount of time on a smaller number of objectives. We give a large proportion of our time to counting and to working with numbers, so covering addition, subtraction, multiplication and division. We follow a concrete pictorial approach just like they've done in early years. So we start off with objects and move on to pictures before doing it just in our heads. We show the children a wide range of representations for different things. So we might use object pictures, but also part whole models, bar models, number lines, blank number lines. We do intelligent practice, so that's working out the links and connections between different numbers. So if you know that 5 adds 6 makes 11, then you would know that 6 and 5 makes 11. Because they're commutative, you can switch the numbers around and still get the same answer. And we do lots and lots of problem solving so they can apply all the methods that we are teaching. So this is what the structure of a normal maths lesson looks like. The start of every lesson we do about 10 minutes counting before moving on to an arithmetic task, which is just some quick fire number bonds or additional subtraction questions. We then would move on to a problem of the day, which is linked to what a past objective we might have taught for a problem solving skill. We then move on to the teaching input, where we teach them the main lesson objective for that day, and then they go and work independently at their tables, or they might be supported by a teacher or a TA. If they're a fast finisher, to extend their learning, they do something called a brain stretcher. And this is a problem solving task which is linked to each lesson's objective. So as mentioned, we spend about 10 minutes counting at the start of every maths lesson. Counting underpins successes in all areas of maths. If they can't count very well, then they're going to find addition, subtraction, multiplication and division very difficult. They need to be able to count in ones forwards and backwards to and from 100, and also starting from any number. In Year 1 we count in multiples of 2s, 5s and 10s through chanting and counting games, and in Year 2 they cover the 2s, 5s, 10s and 3 times table, and then towards the end of the summer term they start learning the 4 times table to get them ready for Year 3. What's really important when we're counting is we're listening out for the pronunciation of teen and T numbers, and also we're checking that they're dropping back into each tens area really carefully. So they might go 52, 51, 50, 59 again, rather than dropping back into 49.
Okay, so this next video will show you an example of our Year 2 children doing their counting chants. We call these the rolling numbers, and if you click on the link, you should be able to watch them.
King, good as gold. Let me see your fingers rolling twos. Yeah, 2, 4, 6, 8. Who do we appreciate? 10, 12, 14, 16, 18, 20, 22, 24. Do you want to hear some more? We can do our tens. Let's do our tens. 10, 20, 30, 40, 50. 60, 70, 80, 90, 100. Rewind. 100, 90, 80, 70,
This next video shows the Year 2 children practicing an example of their 10 times tables with the TT Rockstars theme tune. So the children have a different tune with each times table. Again, they really enjoy the repetition, and obviously the musical instruments help as well. So as mentioned before, arithmetic is a 5-minute part of the lesson where the children are doing quick calculations, which is always linked to their prior learning. This is all about the children becoming fluent and developing a flexibility with their numbers. So as you can see an example below, we've got some number sentences. You might either have some missing numbers. They could be related just to addition, or we might then eventually, as they progress further into Year 2, mix the sums up so it becomes some multiplication, some division, some addition and some subtraction.
So as mentioned, the problem of the day is about 5 minutes long. It's just a quick problem solving task, and we can either do it as a whole class or record it in books, and it always links to their prior learning. What's really important with the problem of the day is we always ask them to explain their reasoning, so they're not just telling us the answer, but they're telling us how they've worked it out or how they know the answer is. So for example, down the bottom there it says, Ben says it's easy to know if a number is a multiple of 5, do you agree? So most children can already say yes, but it's understanding how they know the answer, and we'll be looking for something along the lines of, if it's a multiple of 5, it will end in a 5, or so the main objectives in Year 1, first of all, we would focus on counting up to 100, backwards from 100, on or back from any number, and also counting in 2s, 5s and 10s. We would cover place value up to 20 and a little bit higher than that, so that the jump between Year 1 and Year 2 isn't so big. We cover the 4 operations, which are subtraction, addition, multiplication and division. For time, we would teach o'clock and half past. We cover 2D and 3D shaped names, and also a little bit about the properties linking on from what they've learnt in early years. And we also cover measurement and fraction.
So the main objectives in Year 2, we cover place value, but we go up to numbers of 100. We do the 4 operations. We look at time, o'clock and half past, but then we extend on to quarter to and quarter past. We look at 2D and 3D shapes, looking at their names and their properties. And then we do measurement, length, height, mass, capacity and volume. And then with fractions, we do halves, quarters and move on to thirds.
So for place value, we learn about 1 and 2 digit numbers, so numbers like 9 or 20 that have got 2 digits in it. We cover 10s and 1s, so we're learning that in a 2-digit number, the first digit tells us how many 10s are in the number, and the second digit tells us how many 1s are in the number. And that position of the digit therefore determines its value. At this point, especially in year 1, we're looking out for digits in the wrong order. So they might have 0, 2 instead of 20, or 0, 1 instead of 10. And eventually, as we move through teaching more about place value, they will make that mistake less and less. To do place value, we show them in loads of different ways using different apparatus. And again, we follow the concrete, pictorial, abstract approach to help. This is how we would introduce place value to the children. So if we have a look at the number 37 there, first of all, we would show it with deans, which are the sticks and the little cubes you can see. So 37 has 3 10s, making the 30, so you get 3 lots of 10 out on the sticks, and 7 1s, so you get 7 cubes out to represent the 1s. We would then move on to show them in lots of different ways. So we might use straws and use bundles of straws to show the 10s and individual straws to make up the 1s. We could use place value counters, which you can see on the left. We might use 10p's and 1p's, different coloured counters, place value arrows, or even shapes and pictures.
Okay, so this is an example of a worded problem that we would move on to with regards to place value. You can see that we're hoping that the children would make the link between the shapes and their place value digits. So the 2 triangles are representing 20, and then the 5 squares are representing 5 1s. You can then see below, we hope that the children will make the link with their place value knowledge, linking it to the 3 triangles, making it 30, and the 4 squares, making it 4 1s. So the whole number would be 30.
So for addition and subtraction, in year 1, we have to be able to add and subtract 1-digit numbers, including 0, and add and subtract 2 digits and 1-digit numbers.
In year 2, we add 3 1-digit numbers. So you can see the example, we've got 6 plus 4 plus 7. We would try and encourage the children here to make the relationship to their number bonds to 10, the link. So 6 add 4 would be your number bond to 10, then you would just add your 7. We also add and subtract 2 digits and multiples of 10, so 45 plus 50, or 72 take away a 30. And we also add and subtract 2 2-digit numbers with and without regrouping, so 35 plus 17, or 72 plus 20.
These are the methods we would follow for addition and subtraction. So we start off very similar to like what they would have done in early years and recap and build on that. So we start with objects and pictures, and then we move on to doing it with number lines or blank number lines, part whole models, bar models, and then eventually we take all the apparatus away and we learn that we would put the greatest number in our head if we're adding, the smallest number on our fingers, and we would count on. If we are subtracting, we put the greatest number in our head, the smaller number on your fingers, and we count backwards. We also make sure that we show the children calculations in lots of different ways, so that the equal sign's not always at the end, or then they might have got the answer but there'll be a missing part in the middle. In this video, a girl from year 1 is going to show you how she would work out 9 add 4 with the objects.
So Eleanor, what are you doing first? Why are you counting out 9? It is the greatest number.
3, 4, 5, 6, 7, 8, 9.
Now what are you going to do? Add 4 more on them. So what's the answer? 13. Well done.
And this is how we would move it on, by taking away the objects and working it out mentally. So we put 12 in our heads, 8 on our fingers, and we leave our fingers up, but we carry on counting the remainder.
Okay.
First put 12 in your head, then put 8 on your fingers, 4 and 4 basically. So then, and then you go 12, 13, 14, 15, 16, 17, 18, 20. Like a number to 20.
And we follow a similar structure for subtraction. So again, a child from year 1 is going to show you how they would work out 9 take away 3 with opposite.
First get 9. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Now what are you going to do?
Take away 3.
And how many's left?
1, 2, 3, 4, 5, 6.
Is that the answer?
Yep.
And to work out subtraction mentally, we would still put the greatest number in our head, the smallest number on our fingers, and this time as we're subtracting, we count back by putting the fingers down so it looks like we're taking away.
First put 17 on your head and 8 on your fingers, then count back. 17, 16, 15, 14, 13, 12, 11, 10, 9.
So here we have a couple of typical SATs style questions for addition and subtraction. If we look at the problem on the right hand side, we can see that there are 55 cakes, 20 boys and 19 girls each take a cake. How many cakes are left? So we're hoping here that the children would first of all work out that they are having to add the 20 and the 19 and then obviously taking away from the 55. So it's a two-step problem. We encourage the children to show their workings. Often they might get a few more marks, but we can also then detect where they may have made a mistake.
For multiplication in year 1, we have to be able to solve one-step problems using objects, pictures or arrays with the support of the teacher.
In year 2, we recall and use multiplication facts for the 2s, 3s, 5s and 10s. This is also where we link in the TT Rockstars. We have to recognise odd and even numbers, and we have to show that multiplication can be done in any order. So therefore we might have 3 times 4, but then we know that we can switch it and say 4 times 3. And we then move on to solving problems using the multiplication knowledge. So in year 2, we use a range of methods for multiplication. Firstly, we would encourage the children to do their skip counting, where they would be using their fingers for support. 2, 4, 6, 8, 10. There's an example of this in the next couple of slides. And we would also do repeated addition, 5 plus 5 plus 5 plus 5. This is the same as 5 times 4. So we would encourage the children to sort of say, we've got 5, we like it so much we do it 4 more times. And then we have, we teach arrays, and you can see an example of this on the right hand side of the slide. This array's got 3 columns and 5 rows. This represents 3 and we do it 5 times, so 3 times 5. We also encourage the children to learn that we can switch our multiplication to be done in any order. There's an example of this on the next slide. So here we have a year 2 child demonstrating how we would do an array with 5 times.
Okay, Mia, draw me an array to show 5 times 3. 1, 2, 3, 4, 5. And how many times are you going to do that?
3 times.
3 times.
Done my 3 times. Now I need to count in 5s 3 times.
And then?
5, 10, 15.
Perfect.
So here we have another child demonstrating the method of skip counting.
Okay, Stanley, how are you going to work out 5 times 6? What are you going to count in?
Your 5s.
And how many fingers have you got at?
6.
Okay, off you go then.
5, 10, 15, 20, 25, 30.
And what's the answer?
30.
Well done.
So this is another example of a SATs question where we might have the children obviously demonstrating their knowledge of arrays or their knowledge of skip counting. The classroom here has 6 tables. Each table has 5 children sitting at it. So the children have to first complete the number sentence. We would then encourage them to obviously show their workings out. Some children might actually draw 6 tables with sort of 5 crosses inside each table. Other children might do it as a natural array.
For division in year 1, it's very similar to multiplication. We just have to be able to solve one-step problems using objects, pictures or arrays, and again it's only with the support of the teacher.
In year 2, we recall and use division facts for the 2s, 3s, 5s and 10s multiplication tables. We also recognise odd and even numbers, and we know that division cannot be done in any order, unlike multiplication. We also then move on to solving problems using division. So with division, we have a range of methods that we would use. We would do sharing, grouping, arrays, or we would then eventually teach them the inverse of multiplication. You can see an example here of where the children have had to group their objects into 3, therefore showing 4 groups. So 12 divided by 3 equals 4. So here we have another video of a year 2 child showing the method of sharing.
Okay, show me 10 divided by 2. Yeah, nice 2 big circles. And now you're going to share your 10 between them. Okay, what's the answer? 5, because one person's got 5.
So here we have a couple of examples from a SATs paper. If we look at the question on the right hand side, we've got the shopkeeper has 20 fish and 5 fish bowls. He puts the same number of fish in each bowl. So again, the children hopefully will share out the 20 fish between the 5 bowls.
For fractions in year 1, we have to be able to recognise, find and name a half as one of 2 equal parts, and we do that for objects, shapes or quantities, and then we repeat the same process again to find a quarter and to know that a quarter is one of 4 equal parts. We would teach this through sharing, so with objects we might share them out if we're finding a half between 2 people, or if we're finding a quarter we would share it out between 4 people, and then we move on to doing it by an array.
In year 2, we recognise, find, name and write fractions of a length, shape, set of objects or quantity. We also write simple fractions, for example, half of 6 equals 3, and recognise the equivalence of. So we encourage the children to make the link between fractions and multiplication. So 3's go into 6 2 times.
Okay, so ways that you can help at home. Wherever possible, just practice counting as much as you can, so whether it's counting up to 100 or backwards from 100, or you might do some ping pong counting where you take it in turns to say numbers where you're counting forwards and backwards. You could be driving in the car and you could practice some quick fire questions related to addition, subtraction, division or multiplication. Where possible, keep practicing your number bonds to 10 and 20 at home, as these help the children spot the links when they're doing addition and subtraction questions themselves, and they can find the shortcuts to help make it quicker. We also send home weekly homework in year 1 and year 2, and this year everybody in the school has got a Numbots log on where you can go online and practice your addition and subtraction, supertising and your number bonds. And in year 2 they also get a TT Rockstar log on to try and practice their times tables.